Good evening.
वहां से नहीं अलाउ
हेलो
करेगा ऑडियो।
हेलो गुड इवनिंग सर नो सर यू आर नॉट ऑडिबल
No, sir. We are not done.
Yeah, good evening. Am I audible now?
yes sir
Yes, sir.
Okay, let's continue. So, today we'll continue with metals and non-metals. Let me share the screen. So in the last class, we had done some reactions of metals, all right? So do you remember we had done the reactions of metals, we had done the reactivity of metals. Today, I will do one of the displacement reaction of metal, which we also call as the thermite reaction. And apart from that, we'll be doing extraction of metal, which we call as metallurgy. Just one. Metallurgy. So, okay, so we had done this chapter up to here. We had done all these reactions. We had done displacement reaction also. We had done the reaction of metals with oxygen. We had done these questions also. Okay, how do metals and non-metals react? We were doing about the ionic bond or electrovalent bonds. All right. So what are ionic or electrovalent bonds? इसको पूछ लीजिए तो खुद उसको कपड़े पे उसको नहीं उसको पूछो दीपक को कपड़े पे कपड़ा. Okay. So what are ionic and or covalent ionic bonds? Moksha? Moksha, what are ionic bonds?
Yes,
Moksha,
sir.
am I audible to you?
Yes, sir.
So Moksha, what are ionic bonds?
Sir, it a type of chemical bonding involves electrolysis between two opposite charges.
All the bonds they involve electrons. But what is so special about the ionic bonds? Why are they called ionic?
In two different atoms, they share each other atoms to form a stable atom.
See, ionic bonds, they are formed between ions, or you can say that ionic bond is formed due to complete transfer of electron. एक और दीपक ले लो, इसमें कपूर जला दो। लो। तो ये लो। ये लो, दीपक जला दो। Okay, so see the ionic bond, it is between the two ions. And how are the ions formed? Ions are formed by the transfer of electrons. So that is why we say that ionic bond is formed due to the transfer of electrons. Alright? Okay, what can we say about the strength of the ionic bond? Huh? इसमें बत्ती नहीं बत्ती लाओ बत्ती बना लाओ
They are strong.
they are strong, so ionic bonds are very strong. How can we say that the ionic bonds are very strong?
Due to the strong inter-ionic force.
Due to
intermolecular forces strong.
but how do we know that these intermolecular forces are strong?
Sir, because of complete transfer of electrons.
See, because of the complete transfer of electrons, the ionic bonds are very strong, and this is evident from their high melting and boiling point. Okay, ionic compounds, they have a high melting and boiling point because of, so ionic bonds, they have high melting and boiling points, right? इसमें रखो, अब तेल डालो. So ionic bonds, they are very strong, as it is evident from their melting and boiling points. So if you observe the melting and boiling points of this, there is a list of few of them. For example, for sodium chloride, the melting point is given as 1074 Kelvin. Boiling point is 1686. So it's very large. It's very large. All right. So because of this, it is said that the bonds or the ionic bonds, they are very strong. The substances which form the ionic bonds, they generally have crystalline structure. So they are made up of strong crystals. All right. What about their conductivity? Yeah. Yes. What
Yes,
about
sir.
their electrical conductivity? Are these ionic compounds good conductors?
Yes, sir, they're good conductors.
Okay. So ionic compounds, they are good conductors. All right. But in what state? These ionic compounds, they are in the solid state. The ionic compounds are not good conductors. They are poor conductors of electricity. But in their molten state, they become good conductors. As they become free ions. In their molten state, they turn into free ions. So in the molten state, they become free ions. Therefore, they are able to conduct electricity. Right? Whereas in their solid state, they are in the form of combined atoms. So therefore, they do not conduct electricity in their combined state or in their solid state. What about their conductivity in the aqueous solutions?
They are good conductor in aqueous solution.
They are,
Good conductor in aqueous solution.
yeah, they are good conductors in their aqueous solutions. How can we say that they are good conductors in their aqueous solutions?
Because
Because
at the time they are in molten state.
they form ions. Okay. So they form ions. That's why we can say they are good conductors. So these ions, they help in the conduction of electricity. Okay, so these are some of the properties which we had studied. That for the ionic compounds, the physical nature, ionic compounds, they are solids and they are hard because of the strong force of attraction between the positive and negative ions. Melting and boiling points. So ionic compounds, they have high melting and boiling points. About their solubility. So these compounds, they are generally soluble in water. Why they are soluble in water? Because water is a polar compound. Okay. So water is a polar compound and they are ionic compounds. So therefore, most of the ionic compounds, they are soluble in water. So the bonds between the molecules, they break in water. Conduction of electricity. So in the solid state, they are not good conductors, but in their molten state, they are good conductors. All right. Check it out. So in their solid state, they are not good conductors, but in their molten state, they are good conductor. Also in their aqueous solution, they are conductor. So write the electron dot structure for sodium, oxygen, and magnesium. So let's see how do we write these electron dot structures. While writing the electron dot structures, we write the electrons in the outermost shell. Okay, what are the number of electrons in the outermost shell? We write only those atoms. So see, answer to the first question, we'll write here sodium, see represented by its symbol Na. And how many valence electrons are there for sodium?
Electric configuration is 281.
281. Its configuration is 281. So its valence shell has just one electron. Okay, so we'll be representing it by one dot. Just one dot will be represented over this. So here we write here just one dot. We represent here one dot, which will represent sodium ion, sodium atom with just one electron. For magnesium, if I make the same for magnesium, so I'll write here symbol Mg, and magnesium has configuration 282. Okay. So I will represent here two dots. I will draw here two dots. So this is the electron dot structure for magnesium. Now all of you draw the electron dot structure of oxygen. Sumuk, draw the electron dot structure of oxygen.
Yes, sir.
So have you drawn the structure? Yeah, have you drawn? Siddhisri? Siddhisri?
Yes, sir.
Siddhisri, how many electrons are there around oxygen?
Sir, 6.
Siddhisri, am I audible?
Sir, can I answer?
Yes, you answered, I think. I heard your answer. You said 6. All right. So there are 6 electrons. You represent here 6 electrons around oxygen like this. So even this is correct. Even if you represent these two dots over here, that one is also correct. So this is our oxygen. Next, see question number 2. We have to show the formation of Na2O and MgO by the transfer of electrons. So how by the transfer of electrons we will show this formation. Let's see here. We have to show the formation of Na2O. So first we make the electron dot structures of Na as well as oxygen. Right. So let's make here We are showing here the formation of Na2O and NGO. So for Na2O, we write here Na and write one electron over it. For oxygen, we write 6 electrons. So it's 1, 2, 3, 4, just 1, 3, 4, 5, 6. Okay. So, Huria Ishaq, can you tell me how many electrons are required by oxygen to complete its octet? Yeah, Huria. Huria Ishaq, am I audible? Sumuk?
Sir, could you once again repeat the question?
How many electrons are required by oxygen to complete its octet? Two. Okay. So Aryan, your answer is correct. It's 2 electrons. Oxygen requires 2 electrons. All those cameras which are not on within the next 2 minutes, you will be informed through the group. Please keep your camera on. So for oxygen, you have 2 more electrons are required, and every sodium has just 1 electron. So how many sodium atoms do we need now? How many sodium atoms need here? We need 2 sodium atoms, as there are 2 electrons required, and every sodium atom can contribute only 1 electron. So how will it be? We need 2 sodium atoms, and there will be transfer of electron from this sodium to this oxygen. Again, transfer of this electron from sodium to oxygen. Okay. So we will have here now the formation of sodium ions. So we will have 2 sodium ions, Na plus, one more Na plus. Due to donation of electrons, they will turn Na plus, right? And the oxygen here will have 8 electrons now. You can write 1, 2, 3, 4, 5, 6, 7, 8, showing here a negative charge of 2. Okay, Sumuk, you are having problem with your camera. Okay, okay, so anyways, no issues. So for oxygen, I can write here O. It has a charge of -2, so it will be represented as O minus 2. So the ions are formed, and next they will form their bonds. So I can show this formation of Na2 now. Got it, everyone? This is our Na2. Na donated 1 electron from each side, become Na plus. So there is a bond between sodium and oxygen. There is a bond between sodium and oxygen. Similarly, can you show the formation of NGO?
Sir, here also.
Yeah, Siddhisri, what about your mic? Is your mic also not working?
Sir, 2 bonds of magnesium are been shared with 6 bonds of oxygen in MgO.
Not bonds, we call them electrons. So two
Electron,
electrons of oxygen, okay,
electrons, sir.
2 electrons of magnesium, they are shared with the oxygen. So the single oxygen is gaining the 2 electrons. So we write here Mg. First we write Mg, its electron dot structure. Then we write oxygen, we write its electron dot structure as 1, 2, 3, 4, and 5, 6. Now we show the donation of electrons. So these 2 electrons, they are donated to the same oxygen atom, giving rise to the formation of Mg plus ion, Mg2 plus ion, and you have oxygen plus minus 2 ion. Okay. So now the bond between them is formed, which is MgO. This gives the formation of, you can write MgO. All right. So I think these questions are clear to everyone.
Yes, sir.
Anyone having any doubt? So see, finally, how you have to represent? You have to first you have to show, make the each of the atom show the transfer of electrons. Then write their charges, write the ions, which will represent the compound. So like here I did, either you show like this, you represented the ions. So either you show like this, they combine together to form MgO, or you represent like this. You write here Mg, write here as 2 plus, it's or this one, Mg 2 plus. You write here oxygen minus 2. So these are the 2 ions, and hence your compound MgO is formed. The same can be shown here also. So if you have 2 NS, you can write here Na plus. So this is 2. And you have oxygen, that is just 1. Minus 2, this is just 1. So in this way, you can show the formation. Okay, just try one more. Show the formation of CaO, calcium oxide. Show the formation of calcium oxide. Yes, everyone. I'll just check through the camera for everyone. Do this.
Sir, my camera is not working.
Okay, Abhinav, camera is not working. Okay, you share your answer in the chat. Yeah, take a click, share the click to the chat. Can you do this? Okay, so is how many of you have shared the answer? I didn't receive any of the answers right.
Sir, like that textbook one, we have to make that, no, sir.
Hmm?
Sir, in the textbook, no, we have to do like that only, no, sir.
Yeah, either you do like that, or I have shown you. You can show like this. See, sodium atom with electronic configuration, transfer of electrons. Then you show the formation of ion, and after the formation of ions, you write the formula like this.
Okay, sir.
Abhinav, have you done? Okay, Huriyas, check your camera is not on, then please. Sumuk, calcium does not have 8 electrons. Calcium has only 2 electrons. And they are not shared, they are transferred.
Sir,
Okay. Yeah, Aryan, just show the charge on oxygen. Write the charge on oxygen also is -2. All right.
sir, complete.
Yeah. अरे अरे बंद करो बोर्ड बंद करो बोर्ड बंद करो yes so we write Ca with 2 electrons, just 2 electrons in the outermost shell. Oxygen having 8 electrons, 6 electrons in the outermost shell. So 1 2 3 4 5 6. Then show the transfer of electrons here. The 2 electrons being transferred. So it's forming Ca2 plus ion. It's forming Ca2 plus ion. Oxygen is forming O minus 2 ion. So you can write them in square brackets. Ca2 plus combining with oxygen minus 2. So the 2 ions have been combined together to form calcium oxide. Try to form this one also, calcium chloride. Yes. Okay, who all have got the answers? Calcium has plus 2 electrons, oxygen has minus 2 ions. Okay, all right. See, all of you know the answer. The point is how we write the answer. Okay, so learn to write the answers. Now we move to the next question. You have to, what are the ions present in these compounds? So what are the ions present in sodium oxide and magnesium oxide? Yes. What are the ions present in sodium oxide and magnesium oxide? Abhinav, what are the ions present?
What, sir?
What are the ions present in sodium oxide and magnesium oxide?
Sir, Na plus and O2 minus.
Yes, in sodium oxide, we have sodium ion and oxide ion. In MgO, we have magnesium ion and oxide ion. Then why do ionic compounds have high melting points? Yeah. Moksha? Moksha, yeah. Why do ionic compounds have high melting points?
So because of the more stable.
Yeah. Why they have high melting points?
Because of electrostatic forces.
Yeah, because of the because of the strong electrostatic forces between the two ions. Okay, all right. Because of the strong electrostatic forces between the ions, the ionic bonds have high melting points. Now we see occurrence of metals. We know that the metals are very important for us. and we find those metals from the earth's crust only. So all the metals, they are obtained from the earth's crust. So if I find out the metals, so in what form do I find them? In what form do I find those metals?
In oxide.
In
Oxide forms or ores.
most of if you look up at the reactivity series. Now we again move to the reactivity series, and if I observe in the reactivity series, so in the top you have potassium, sodium, calcium, magnesium, okay, aluminium, zinc, iron, lead, hydrogen, copper, and mercury, silver, and gold. So if you see their reactivity series, silver and gold are the metals which are very less reactive. So silver and gold, they are the metals of least reactivity. So they are found in their native state. Native state means they are not found as some oxides or sulfides. They are found as pure gold and pure silver. And also it doesn't mean that you will be finding that gold as a gold biscuit that you see in movies. Okay, it's not that like you dug a soil and over there you'll find a complete mountain of gold. It's not like that. Okay, there are gold particles which are very tiny and they will be mixed with the soil. So the method is like purifying that, removing the soil from there. Just by removing the soil, if you remove the soil, you will be able to get the gold particle. You must have seen that show on Discovery, which we see as uh, I don't know, I don't remember the name. They have the diggers, or we say gold diggers. Has anyone seen that show? Gold diggers?
Gold
Yes,
rush.
Gold Rush. Yeah, maybe Gold Rush. I don't exactly remember the name. It's Gold Diggers or
Gold rush.
Gold Rush. Okay. No, Gold Digger, no, it's Gold Rush. Okay. So in that, the people, yeah, yeah. So this is the show where the people, they are continuously searching for gold in the soil. They keep on mining. So they keep on mining. First, they analyze the soil of an area. If they found that yes, sufficient amount of gold can be extracted from it, then they use it. Okay. Then they use the gold. Then in that area they perform gold mining. Right? If they see that yes, there is not enough gold, so they don't mine over there. The target is that you should be able to get the sufficient amount of gold. Right? So these metals, which are low, even in the reactivity series, they are found in their free state. So they can be just obtained. They can be just obtained with a little bit of purification. Those at the top of the reactivity series, like potassium, sodium, calcium, magnesium, aluminium, zinc. Okay, so up to aluminium, these metals are said to be the metals with high reactivity, and they can be purified only with the help of electrolytic refining or electrolysis. So by the process of electrolysis, these metals are extracted as they are high in the reactivity series. Those which are middle in the reactivity series, like starting with zinc, iron, lead, hydrogen, copper, mercury. Hydrogen we don't extract. Hydrogen, as you know, is obtained by the electrolysis of water. Okay. So by the electrolysis of water, we can obtain hydrogen. Zinc, iron, lead, copper, mercury, they are they occur all these they occur in the combined form. So even the highly reactive and the medium reactivity, they occur in the form of compounds. So potassium occurs in the form KCl, sodium occurs in the form NaCl. What is the main source of sodium? Can anyone tell what is the main source of sodium from where we can extract sodium?
Rock salt
Rock salt. And where do we get that rock salt?
from ocean.
From ocean. So can I say that ocean is the biggest source for the rock salt?
Yes, sir.
Yes. So ocean is the biggest source for the rock salt. Now the calcium. See? So calcium, how we obtain this calcium? From wherever you obtain calcium, from wherever you obtain sodium. Calcium is obtained as calcium oxide. It is also obtained at calcium carbonate, limestone. So limestone is the main source for calcium. All right. Magnesium occurs in the form of its oxide. Aluminium occurs as alumina, Al2O3. The ore of aluminium is called bauxite. So this is alumina, Al2O3. This is called as alumina, but its ore is called as bauxite. So bauxite is the ore of aluminium. It's ore of aluminium. There are different other ores of aluminium. Alumina, bauxite, these are all ores. Then zinc has an ore called zinc sulfide. Is an ore of zinc. Iron occurs in the form Fe2O3 or Fe3O4. So Fe2O3, it is called as hematite. The contents of Fe2O3, they are found in the ore which contains Fe2O3 is called as hematite. And the ore which contains Fe3O4 is called as magnetite. So these are the two ores of iron which we call as hematite and magnetite. So hematite and magnetite, these are the two ores. Lead. So lead also occurs in the form of lead sulfide and lead oxide. Generally, these are the forms in which lead is formed. Copper occurs as copper glance. We call the ore of copper to be copper glance. Represented by CuS, copper sulfide or copper oxide. Then mercury. The ores of mercury, they are called as amalgam. All the ores of mercury, they have a specific name. The ores of mercury are called as amalgam. Right? So in the next class, we'll continue with this extraction. So today we have seen that how the metals occur. Some of the metals, they occur in their native states. Some of the metals, they occur in the form of their ores. Okay. Those which are high in the reactivity series, they can be separated by the process of electrolysis. We'll see how the ones which are at the bottom of the reactivity series, how they can be separated. All right. So any doubt in today's class?
No, sir.
No. Okay.
No,
Okay. All right.
Thank you,
Okay.
sir.
Thank you,
Bye,
sir.
sir.
Bye, all of you.
Sir.
Thank you. Sitisvi.